Hi guys, this is Kavina. Welcome to our YouTube channel. Today we are going to learn Pythagoras theorem. In Pythagoras theorem, the statement says that in a right triangle, the square of hypotenuse is equal to the sum of squares of other two sides. Here in this is the right triangle ABC and the hypotenuse side is the opposite of the 90-degree angle is the hypotenuse. Now we have to prove AC square, that is square of hypotenuse, which is equal to other two sides. Other two sides are AB square plus BC square. This we have to prove because it is given in the statement itself, that is the square of hypotenuse. In this hypotenuse is AC square and the other two sides are AB square and BC square. This equation we have to prove. Next, to prove this equation we need to construct. The construction is, we are going to draw a line BD. We are going to draw a line BD perpendicular to AC. BD perpendicular to AC. Draw line BD perpendicular to AC. Construction. Now we will go for the proof. First, we are going to take the full triangle. This whole triangle, ABC triangle, triangle ABC and triangle first half, ABD or ADB. ADB. In this triangle, angle B and angle D is equal to 90 degree. Because first only we have said angle B is 90 degree and we have drawn a perpendicular line to the AC, so the angle D is also 90 degree. These two triangles are similar. Triangle ABC is similar to the triangle ADB. So we are going to take the corresponding sides of these triangles. So corresponding sides are AB by AD is equal to AC by AB. That is AB. This side corresponds to this side. This side and side AB corresponds to side AD, which is equal to AC by AB. AC by AB. The side AC corresponds to side AB. These are the corresponding sides of the similar triangle. That is, side AB corresponds to side AD and side AC corresponds to side AB. Now we are going to cross multiply this. If we cross multiply AB into AB, AB square, which is equal to AD into AC. We are considering this equation as equation 1. Next, we are going to take the whole triangle with this second half of the triangle. The whole triangle is triangle ABC and triangle BDC. Okay, first the whole triangle, the next is the half of the triangle BDC. Now, this triangle is also similar. Triangle ABC similar to triangle BDC. Now we will take the corresponding sides of this triangle, that is BC by DC. BC by DC is equal to AC by BC. AC by BC. First, BC, we are going to take the triangle side BC by DC is equal to AC by BC. If we cross multiply, BC into BC is BC square, which is equal to AC into BC. This is equation 2. Adding equation 1 and 2. We get now equation 1 AB square plus BC square. First LHS we are going to add AB square plus BC square, which is equal to, next RHS, AD into AC plus this side, equation 2 RHS, AC into BC. Now we'll solve this. By solving this, we get AB square plus BC square is equal to, now in these terms, what is common? AC. So we'll take AC outside and put the other two terms inside. Now what is remaining? AD. We'll write AD plus AC is already taken outside, so remaining is DC. Okay. Next, we are going to solve again. AB square plus BC square is equal to AC as it is will write, and AD plus DC what will check? AD. This is AD plus DC. If we add AD and DC, we get the whole side, that is AC. So AC into AC, the whole side. If we add these two sides, we get the whole AC. So we are going to add, if we add this, we get AC. If we multiply, AB square plus BC square is equal to AC square. We have got what we have to prove. Hence, proved. Hence, Pythagoras theorem is proved. We should get this only, no? Check to prove what we should prove. Same, the AC square is equal to AB square plus BC square, which is proved now.